Okay, so we're going to look at chapter 2, and in chapter 2 we'll be looking at populations and what sustainable ecosystems are. So we have to talk about, or review what a population is. A population are all the individuals of a species that occupy a particular geographic area. So we could talk about all the squirrels in a forest. We could say all the squirrels in the forests in Ontario. We could say all the squirrels in the forests of Canada. So the geographic area is very important for a population. And what is exponential growth? So populations have a growth curve, and accelerating growth that produces a J curve is what's called exponential growth. And it happens when populations of organisms reproduce faster than they die or leave an area. And this happens when an organism comes to a new habitat that has a lot of resources, or pressure is removed from a population. So the human population is accelerating exponentially. So this would also represent what our population looks like, this J curve here. In this example, this is a population of elephants in South Africa's Kruger National Park. So we see here that their population was increasing quite slowly, but once they became protected in 1960, then the growth became exponential. So they didn't have any more pressures, they weren't being hunted anymore. So that caused them to grow exponentially. Another example are wild turkey populations. They disappeared because forests were removed and there was hunting. And in the 1990s, they were then introduced to areas that had resources to support turkeys. So this then caused the turkey population to grow exponentially. Now, why can we not sustain exponential growth for a long period of time? This is because no ecosystem has an unlimited supply of resources that organisms need. There are limiting factors that limit the growth, distribution, or amount of a population in an ecosystem. So some examples of this would be food, water, oxygen, space availability, predation, competition, and urban sprawl. So those are all factors that limit the growth of a population. Can you think of what is limiting the human population? What would be the answer to that question? We currently have unlimited resources for the most part and very little competition. Therefore, this is why our population is growing exponentially. Now, when populations start to level off, this is what's called the carrying capacity. And it happens because the size of a population can be supported by the resources and environment. So at some point, the population will run out of resources. So the carrying capacity, it means that there's no longer a growth. So the amount of births equals the number of deaths, the amount of immigration equals the amount of emigration, and so on. So it levels off. So in this population here, right, the fur seal population, there is exponential growth and then it reaches its carrying capacity. So there's a few questions for you to answer here. We will answer them together. What year does the fur seal start to experience exponential growth? So we look on our curve and we see where in the graph does it start to actually increase. So if we look across it, somewhere around here, this is 0, they're not the best numbers, but let's say it looks like it's around here, so about 1915. And what is their carrying capacity? So what is the number at this line here? So we look across to the y-axis, and it says breeding male fur seals in the thousands. So if we look at this, we'd say it's approximately 9,000. And what year do they reach this carrying capacity? So when does the curve flatten out? So we look across, and again, it's not perfect. Looks like it's probably around here, right? So say maybe 1936. Okay? So if you were given this on a quiz, we'd make sure that you could see the lines better and get a better number. Okay? But it's approximate for these. So we call this carrying capacity, we call this equilibrium. So this point here, it was our equilibrium, equal, right? That's what the root of equilibrium is, equal. So there's a balance between the number of individuals leaving, death or emigration with an E, or being added, birth and immigration, to a population. Okay? So if there's a resource then being used at a rate that exceeds carrying capacity, the population will drop to a natural equilibrium. Okay? All right, so that is populations and their resources.